Computer vision innovations explode, synthesizing 87 papers from September 15, 2025. Dive into cutting-edge AI research on how machines see the world. From object detection to 4D reconstructions, explore real-world impacts. Presented by AI Frontiers for researchers and enthusiasts alike. Presentation Overview, your guide to today's computer vision breakthroughs. Buckle up for a narrative journey through 87 fresh papers on visual AI wonders. Themes, findings, methods, and spotlight key studies are unpacked with storytelling flair. Imagine peering into AI's visual smarts. What's the next big breakthrough? Optimized for engagement, blending technical depth with accessible analogies. Field Overview. Understanding computer vision. Computer vision enables machines to interpret images and videos like human sight. Key applications include healthcare diagnostics, autonomous driving, and agricultural monitoring. Ties to broader AI occur via deep learning and multimodal fusion for smarter decisions. Challenges encompass data needs and biases. Opportunities arise in ethical, robust models. These papers showcase leaps in efficiency and real-world deployment. Research themes: efficiency on edge devices. Theme 1, making AI lightweight and practical. A key theme is optimizing models for low-resource hardware, like drones or phones. Huang et al.'s Cott-ADNet enables real-time cotton detection in fields with minimal compute. Zager et al. Use knowledge distillation to shrink models without losing accuracy, as in GhostNet v3 Small for tiny images on edge hardware. This bridges lab innovations to everyday uses, such as farm monitoring or retinal segmentation on clinic devices. Research themes: generative and editing techniques. Theme 2, creative AI for image manipulation. Focus is placed on generating and editing visuals, like text-guided photo changes. Yin et al.'s LazyDrag stabilizes drag-based edits and diffusion models for reliable results, unifying drag-based edits with text guidance for stable photo manipulations. Patel et al.'s Dynamo predicts motions in assemblies, aiding robotics and design. Diffusion models are explained as iterative denoising that creates high-quality images from noise, seen in works like generating talking head animations from audio in Deng et al.'s Avatar Sync, or 360-degree garment views in Karas et al.'s HoloGarment. Research themes: robustness and multimodal fusion. Theme 3, handling noise and integrating data types. Building AI resilient to blurry or incomplete data across domains is emphasized. Huang et al. Create radar models that excel in FOD, rivaling expensive sensors with a foundation model thriving in adverse conditions. Sutradhar et al.'s Claire fuses optical and radar for better land cover segmentation via a dual encoder network. Transformers capture dependencies. Attention mechanisms link distant data points effectively, as in multimodal fusion with text, radar, or EEG, such as Li et al.'s NeuroGaze distill, using brain signals for emotion recognition. Research themes: interconnections and overlaps. How themes converge for broader impact. Themes overlap, like efficiency boosting robust multimodal systems in medicine. Torabi et al. Use weak supervision for segmentation, reducing labeling costs, with instance-guided mapping achieving high MIOU on Pascal VOC. Ethical tools, such as Fu et al.'s SCORE, ensure safer generative AI by erasing harmful concepts robustly from diffusion models. Overall, progress drives toward inclusive, reliable vision systems for real-world challenges, reflecting a field maturing with interconnected advancements. Key findings: critical insights across papers. Huang et al. Show raw radar data matches 10 times processed data for 3D sensing, enabling cheap 3D occupancy in fog or dark. Yin et al. Achieve top scores in stable image editing with explicit correspondence. handling complex cases like opening a dog's mouth with inpainting. Chen et al. Recover 4D heart meshes from sparse MRIs with 90% plus accuracy, maintaining high dice scores even from single slices. Karabi et al. Reach 86.6% MIOU in weakly supervised segmentation, cutting costs. These breakthroughs enhance accessibility, reliability, and ethics in vision AI. Methodology. Synthesizing common approaches. Transformers and attention capture long-range links used in radar and editing, as in Huang et al.'s generalizable radar transformer or Chen et al.'s attentive 3D assembly from MRI slices. Knowledge distillation compresses models for edge use, like in Zager et al.'s GhostNet v3 Small. Weakly supervised learning learns from minimal labels, as in Torabi et al.'s IGCAM or Zhou et al.'s OmniWorld pre-training. Diffusion models de-noise for generation, with trade-offs in speed, as in Yin et al.'s LazyDrag or Fu et al.'s Score. Hybrids combine strengths for robust, efficient outcomes across tasks. Selected research papers, Radar Foundations. Paper 1, Towards Foundational Models for Single-Chip Radar. Huang et al., 2025, builds versatile AI for cheap radars in adverse weather. Selected for novelty in creating the largest raw dataset of 1 million samples, enabling cost-effective 3D sensing. The generalizable radar transformer is used for tasks like occupancy prediction, with self-attention for unordered points and logarithmic scaling showing 20% gain per 10 times data. Findings reveal raw data outperforms processed by a 10 times data equivalent, rivaling high-res sensors. Impacts autonomous systems by rivaling LiDAR with 10 times data efficiency. Selected research papers, Stable Editing. Paper 2, LazyDrag, enabling stable drag-based editing on multimodal diffusion transformers via explicit correspondence. Yin et al. 2025 integrates drag and text for reliable image manipulations. Chosen for impact in creative tools, outperforming implicit methods on DragBench with state-of-the-art scores and low FID at 1.36. Explicit maps from user drags are employed, enhancing multimodal transformers like Stable Diffusion with full-strength inversion for fidelity in multi-round edits. Revolutionizes media editing, fostering human-AI collaboration with ethical considerations amid deepfake concerns. Selected research papers, 4D heart recovery. Paper 3, End-to-End 4D heart mesh recovery across full-stack and sparse cardiac MRI. Chen et al. 2025 reconstructs heart motion from incomplete MRI data. Selected for representativeness in medical AI, handling sparsity down to one slice for surgery aids. TetHeart uses deformable tetrahedra, initialized from full stacks, with attentive 2D to 3D fusion and weak supervision from keyframes. Findings show 90% plus dice on sparse data, generalizing to unseen SEPs. Advances clinical tools, enabling real-time monitoring despite data gaps. Future directions. Outlining next steps in research. Foundation models like Huang et al. Are expected to scale to 100 million samples, integrating with language for synergy in apps like interactive editing. Weakly supervised techniques will evolve to hybrid approaches, blending minimal labels with self-supervision, tackling data scarcity in niches like rare diseases. Multimodal fusion will deepen for embodied AI, extending Shi et al.'s hierarchies to audio vision. Efficiency pushes via distillation and hardware aim for edge ubiquity, such as real-time 4D heart monitoring on wearables. Challenges include massive data needs, noise robustness, and ethical policies for bias and deepfakes. AI synthesis and review. How this deck was created. Synthesis was performed using AI tools, GPT Grok with model Grok 40709 for content generation. TTS synthesis was conducted via OpenAI for narration. Image generation used Google. Review was undertaken by a human expert to ensure accuracy and coherence. Potential oversights may exist. All references are provided for verification. Subscribe and channel info. Join the AI Frontiers community. Subscribe to our YouTube channel for more deep dives into AI research. Title: AI Frontiers. Description: stay updated on cutting-edge papers and narratives. Hit subscribe today. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.